So the first kind of measure of central tendency that I'm going to discuss with you is arithmetic mean. This is the simplest and the most commonly used arithmetic mean. So I can always ask the entire class to tell me what is the average marks in maths that you all got for your plus 2, right? So generally, for any observations, if x is the data, x is the variable whose data you have got, we generally use x1, x2, x3 and so on to represent different observations on the variable x, right? So if x is height of the student, then x1 would be height of the first student, x2 would be height of the second student, and so on. Okay, and the average is then denoted as x bar. Okay, the arithmetic mean, also known as AM, is usually denoted by a bar on top of the variable. So if your data is raw data in terms of x1, x2, x3, etc. till xn, then your arithmetic mean would be x1 plus x2, etc. plus xn whole divided by n, where n is your total number of observations, right, or total number of terms in the sample. Now remember, there's a shorthand notation for this. Instead of every time writing x1 plus x2, etc., that's how you read the dots. The dots are read as etc. etc. till xn. I can use this big sigma, capital sigma sign, which means summation. xi, I going from 1 to n, divided by n. Okay, so remember, the sigma means summation. So if your raw data values are, okay, I'm again taking this directly from your guidebook. If your values are 12, 18, 14, 15 and 16, and you have been asked to calculate its arithmetic mean, x bar is summation x divided by n, right? Which means 12 plus 18 plus 14 plus 15 plus 16 whole divided by, since there are 5 observations, it'll be 5. The numerator total comes up to be 75 divided by 5, which is 15, is the arithmetic mean of 12, 18, 14, 15 and 16. Now instead of individual data, if you have data in terms of frequency tables, what you can do is, so you have values x1, x2, x3 and so on till xn, and the number of times that they appear in the data is denoted by frequency f. So f1 is the frequency for x1, f2, f3 and so on, fn. If you have data represented as this frequency table, then your arithmetic mean x bar, the formula will be summation f times x divided by summation f. So what does summation fx mean? If no superscript and subscript are given, that is nothing is written on top or below the summation sign, that means your I is going from 1 to n. it is understood. 1, 2, to n. So summation fx divided by summation f would mean f1 x1 plus f2 x2, etc. fn xn whole divided by summation f is nothing but f1 plus f2 and so on plus f3, right? So summation f is the total frequency. Let's look at an example and then you will understand this better. So this is the example that I've got. Again, this is directly from the guidebook that I'm using right now. So these are your daily wages in rupees. These are per hour per day wages that are being received. And so this is my x variable. And this is the frequency. Frequency here means the number of workers that receive these wages per hour per day. So 3 workers receive rupees 5 per hour per day. Similarly, 8 workers receive rupees 6 per hour per day. And 12 workers receive rupees 7 and so on. So our x is 5, 6, 7, 8, 9, that is the wages being received, and our f or frequency is the number of workers receiving this wage. So remember, when you have frequency data, your x bar is summation f times x divided by summation f. You can find summation f by adding up the total frequency. So 3 plus 8 plus 12 plus 10 plus 7 is 40, right? And f times x is 5 times 3, 15. Sorry, 5 times 3, 15. 6 times 8 is 48. 12 into 7 is 84. 8 tens are 80. 9 sevens are 63. That comes up to 12, 15. 6, 7. So summation fx is nothing but the sum of fx, that is 290, divided by summation f, 40. So this is the average wages per worker. Remember, the unit of the average would be the same as the unit of x, right? So in this example, I think it was daily earnings, but I have been calling it per hour per day. So be consistent. Here is another example of frequency data, and you have been asked to calculate the arithmetic mean for this data. Now the difference between the earlier case and this case is that you have classes rather than single values for x. So 0 to 4 is the first class and its frequency is 1. 4 to 8 is the second class and its frequency is 4, and so on. Now we know that frequency is f, but what value between 0 to 4 do we take as x? And this x will be the class midpoint. So 0 to 4, remember how to find the class midpoint? The upper limit plus lower limit divided by 2. So in this case it will be, in the first case it will be 0 plus 4 divided by 2, which is 2. Right? 4 plus 8 divided by 2, which is 12 plus 12 divided by 2, which is 6. So your class midpoints in this case will be taken as the x, when you have classified data, class interval data, right? So 2, 6, 10 and 14 will be considered as x for the respective class intervals, right? We are choosing the class midpoint. Once you have the x, your formula remains the same. Your arithmetic mean is summation fx divided by summation f. So summation f can be added up from here, it is 10, and fx can be found by multiplying these two, and 3 into 10, 30, 2 into 14, 28. So that's 2, 24, 30, 28. Use your calculator, find out summation fx. Summation fx is 84. So your arithmetic mean is 84 divided by 10. So summation fx comes here and summation f comes here. And your answer is 8.4. In this example, since I've taken it from the guidebook, there are no units mentioned. But always remember, whatever is the unit being mentioned for x will be the unit for your arithmetic mean as well. So if these were marks, 8.4 marks would be the average mean, average arithmetic mean, right?